computers carry out instructions without much care as to who's giving the instructions. And that's why as cloud administrators, it's absolutely critical that we properly set up authentication and authorization for a secured environment. So when we talk about authentication, we're really talking about the proof of identity. How can someone prove they are who they say they are? Well, one traditional way that's long been in use is simply by supplying a username and a password. And while that's all right, it's not great because that all falls under one category of something you know. It potentially could be learned or guessed and maybe even used remotely by some malicious actor. So we'll cover some additional things that can be done to enhance authentication beyond just username and password. Authorization is different and it can only occur after successful authentication. Authorization means that a user, for example, is given access to a resource based on assigned permissions. Maybe they have the ability to read blobs in a storage account, for instance. In Azure, authentication can occur in many ways. We've mentioned that username and password is one valid mechanism. So users could have an account created for them in Azure AD, and they can have a password set, ideally a strong password that is not easily guessed, and that can be used for authentication. But there are many other types of things that can be used for authentication, such as a key fob, a hardware token device that will need to be inserted in some cases. Some of them have a USB interface. You have to physically have that device with you to plug it in to authenticate to a system. It might even require not only key fob, but also the knowledge of the username and the password. So all three things together to sign in. Authentication can also be biometric. And this is pretty much standard on modern day laptops and mobile devices where it might require a fingerprint scan to authenticate you to the device. Often you just hold your finger against the power button lightly so it can scan your fingerprint that way. Or it could be a retinal scan, a voice scan, facial recognition. All of that is biometric authentication. Authentication can also take advantage of using public key infrastructure or PKI certificates. PKI certificates are digital security certificates that are issued to a user or perhaps a device or perhaps a piece of software, whatever the case might be, to properly authenticate it so it can do what it needs to do, to access some kind of a resource over the network. In Azure AD, authentication can come in the form of user accounts. So creating users in Azure AD, the user signs in and can be authenticated to access things like cloud-based apps, even in some cases on-premises apps if Azure AD Connect is configured. Azure AD authentication can also occur at the device level. We can join devices to the Azure AD tenant. So it can be centrally managed and perhaps used with conditional access policies. That means, for example, that we might have to be using an iOS device from a certain network in addition to having a valid username and a password before we're allowed to access particular apps. So that type of thing is only possible if the device is registered so you can get some of those device attributes. But Azure AD authentication also comes in the form of what's called a service principal. When you register an application in Azure AD, that application in the background is automatically set up as a service principal, which you can use to assign permissions with role-based access control. So let's say that the app you registered needs the ability to read blobs in a storage account. Well, after you register the app, it will have a service principal automatically created that you can assign those blob reader permissions to. A special type of service principal is called a managed identity. It's called managed because it's part of a resource. For example, I could go into a virtual machine and I could enable a managed identity. It could be a user-assigned managed identity where it is not tied to the lifecycle in our example of the virtual machine. That means if the virtual machine is deleted, the user-assigned managed identity for that virtual machine would still exist. Or it could be system-assigned, which means it is tied to the lifecycle of the resource. Either way, it's a way to grant permissions in our example to a virtual machine, specifically any code or scripts running in the virtual machine that might need access to something, like a database or a storage account or whatever the case might be. So these are all part of Azure AD authentication. Multi-factor authentication, or MFA, which is sometimes also called two-step verification or two-factor authentication, 2FA, means that you have more than one category for authentication. Something you are is biometric authentication. It's a unique biometric characteristic, like your retinal scan or your fingerprint scan or something along those lines. Something you know would include things like a username and a password. That's a different authentication category. Something you have could be a key fob that you must possess and insert into a USB port, or maybe it's got a little LCD display you have to type in a code. Or maybe you have an app that does that type of thing on your smartphone, so you must have your smartphone so that you have that app on it with a code that you must enter, perhaps in addition to your username and password. Then there's gesture-based authentication, something that you do, like a certain pattern drawn on a screen or a certain swiping pattern that will allow you to authenticate to a device. So when you combine more than one of these four categories together, you end up with multi-factor or two-factor authentication. And it makes user sign-ins much more secure. It's a lot easier to sign into someone's account or break into it if it's just username and password than it would be if it were username and password and having to have a smartphone with a unique code texted to that phone, where those codes usually only good for 30 seconds anyways. It's much more difficult to crack into that. Picture on the screen, we have a multi-factor authentication screenshot from Azure AD, where we have an alphabetical listing of usernames, and the rightmost column is labeled multi-factor auth status, where some users are disabled. That's the default state of MFA for user accounts. But then we've also got some about halfway down with the status of enforced, and at the bottom we have one with the status of enabled. So the difference here is that when you initially turn on multi-factor authentication, the status for that account is enabled until the next time the user signs in and configures MFA, after which then it switches to enforced. So we know then that authorization can only occur after successful authentication. We've talked a lot about authentication. So authorization really just means having appropriate permissions to access a resource. Whether you're accessing a resource through the Azure portal, maybe you're an assistant cloud admin, and after you authenticate with your Azure AD account, through role-based access control, you are given permissions to manage something like virtual machines. Or it could be a storage account access key. Every storage account has two keys and two connection strings. You only need any one of those to get full access to the storage account. Or a storage account shared access signature, an SAS, a SAS, which is limited access to a subset of items within a storage account. Or maybe authorization would apply to using cloud-based or on-premises applications. As an Azure administrator, you need to be aware of the various ways by which authentication can be used to ultimately grant access to resources. So let's focus on identity federation. Here we're talking about using a centralized trusted authenticator. Now on premises, you could use an Active Directory domain as a centralized trusted authenticator. Specifically, the domain controller servers would be the authentication servers. In the cloud, you could use Azure AD as a centralized trusted authenticator. But with identity federation, we're really talking about having authentication separate from apps. So for example, if you have a website running on a web server, you don't want to build authentication to that website into that web app. Instead, that website, that web server should trust a centralized identity provider that will in turn take care of authenticating users or devices. So that means that apps then would rely upon the trusted authenticator. And that trusted authenticator can span organizations. Now think about that in the context of what you might see when you try to sign into a website online, as we have in a screenshot here. where we can either create an email account, so an email address, where we can create a new account for this web app. We can specify an email address and a password, or we could continue using credentials from some other trusted authenticator. Let's say, for example, that would be Facebook or Instagram or Twitter or Google. If you already have accounts with those providers, there are many other web apps out there that will simply let you sign in with those accounts. That's an example of identity federation as it's used over the internet, but it can be more localized within an organization. Terminology is important here. Let's talk about identity and resource providers. The identity provider, otherwise often referred to as an IDP, can be on-premises or cloud-based. It's a directory service where things like user accounts and groups and device accounts would exist. The resource provider, otherwise called the RP, sometimes also called a service provider or an SP, really is the app that trusts the identity provider. But how is that trust established? Usually it's established through the exchange of public key certificates. So the identity provider public key certificate would be configured on the app server, and that public key would then be used to verify any digitally signed tokens from the identity provider. Because digitally signed tokens are signed with the private key of the identity provider server. If the public key is known by the app, that public key can be used to verify that the signature is actually valid. Another notion that we have to be aware of with identity federation is that of claims. What is a claim? A claim is an assertion about a user or a device. Now, these assertions or claims are contained within a digitally signed security token, so the IDP signs that, and then that digitally signed token is sent to and consumed by an app. But what is a claim? We know it's in a security token. Well, it's just some kind of relevant attributes that were configured for the app that needs to consume them. Maybe the app needs to see the date of birth of a signed-in user, or a subnet IP address for a device, or a security clearance level, an email address. It could be anything. Naturally, when you configure claims on the identity provider, you do that with the knowledge of what is required by apps that will consume those claims. And that means you might have to go into some documentation about the app or talk to the developers of that app, if it's a custom-based app. Pictured on the screen, we've got a screenshot of configuring identity federation settings for an app in Azure AD. Here, it's a security assertion markup language or SAML configuration. This means it will have a SAML token that's digitally signed, in this case by Azure AD, and in step 2 in our screenshot, we can configure attributes and claims, like the user given name, surname, email address, and anything else that might be required by the app. In step 3, we would also specify the SAML signing certificate. This is going to be a PKI certificate along with a private key. Signatures are created with a private key, but they are verified or validated by the related public key. So the identity provider needs to possess the private key, and the app, also the resource provider, the service provider, needs to have the public key to verify the signature. So if we look at the data flow here, in step 1, we have a user trying to access an app. In step 2, the app redirects the user to the identity provider for authentication, and this is transparent. All the user knows is that they're being prompted to enter credentials, or if they've already signed in and single sign-on or SSO is turned on, they won't be prompted again. But in step 3, the user would provide the credentials, whether it's single-factor authentication, multi-factor authentication, and after successful authentication in step 3, the identity provider server would digitally sign the token which might contain claims. Now that token is then sent to the app, and that could be done in many different ways, such as through a web browser cookie that's presented to the app. But either way, in step 4, the user is then authorized to use the app. All of this is transparent. All the user knows is they're signing into an app, and then they're in. So the use of claims then is considered to be a form of attribute-based access control, because permissions to use a resource are based on the values of attributes like a date of birth or an email address or whatever it is that is stored within the digitally signed token as a claim. An important aspect of assigning permissions in the Azure AD environment is having knowledge of service principals and managed identities, what they are, and when to use them. Let's start by saying that when you use service principals and managed identities in Azure AD, it allows code or scripts to access Azure resources with whatever permissions they need, while you do not have to put the credentials in the code or script itself. Now that's important because the last thing you want to do is have custom code, let's say, running in a bunch of virtual machines, and then when the credentials change, you have to go back to all those instances of the code and change the credentials so the code has access to what it needs access to. There has to be a better way, and there is. It's using service principals and managed identities. But we need to explore exactly how that is possible. So let's start by saying this. When we have a service principal, what we're talking about is an object that exists in Azure AD. You don't create it directly. A service principal gets created when you register an app in Azure AD. So a service principal gets created automatically under the hood. The service principal is an object that shows up when you go to assign role-based permissions. And so you can assign those permissions to the service principal, which really represents script, code, or an app. Maybe it's an app that needs to be able to write to a storage account, specifically write blogs to a storage account. Well, that permission can be granted through role-based access control, and it can be granted to the service principal, which represents that app. Now, there are 3 primary types of service principals. There's legacy, which would be useful if you've been using Azure for years and want to continue using service principals as per their first incantation or version. Then there are standard application service principals, which we've just described. They are created in Azure AD when you register an app. And then we have managed identities, of which there are 2 types. So a managed identity is a type of service principal. The first type of managed identity is a system-assigned managed identity. This means that the identity, and again, it's created in the background in Azure AD, the managed identity is tied to the lifecycle of the associated resource. So let's say you go to a virtual machine's properties in the portal and you enable a system-assigned managed identity. Well, that means that if you delete that virtual machine down the road, the managed identity is also deleted. It's tied to the lifecycle of the resource. Although you're not limited to creating managed identities just for virtual machines. That just happens to be the example I'm using. Now, the second type of managed identity is a user-assigned managed identity. This is not tied to the lifecycle of that specific resource, and it can be associated with multiple resources. The way it would look would be as what we have here in our screenshot. We are in the properties of an existing virtual machine, and in the left-hand navigator, we've clicked on Identity. On the right, we then have the option to enable either a system or a user-assigned managed identity. What I've chosen in this example is System. When I do that, it pops up with a message box that says, our virtual machine will be registered with Azure AD, and then you can start assigning permissions to it. Do you want to enable this? And of course, we would choose Yes. Now, that's one half of the work. The second half is actually granting permissions to the managed identity. So in our next screenshot, we are adding a role assignment to our pay-as-you-go subscription as seen in the upper left. Now you can set role permissions to resource groups to individual resources as well. Here it's being assigned at the subscription level. On the left, the role that's being assigned is storage account contributor. So basically, read and write access to a storage account. On the left, under Assign Access to, Managed Identity has been selected. And when you click Select Members, then on the right, you can drill down under Managed Identity. Here I've selected Virtual Machine, and then down below, any Virtual Machine Managed Identities where it's been enabled will show up in the list, and you would select it. So in this case, I would be assigning the storage account contributor role permissions to my Virtual Machine Managed Identity, and because this is done at the subscription level, those permissions would flow down to all resource groups and ultimately to all storage accounts throughout the entire subscription. If it should only apply to one storage account, then add the role assignment to that individual storage account and not the entire subscription. In this demonstration, I'll be working with the service principal. In Azure AD, a service principal represents an application that you can grant permissions to. So there are times when one application component will need access to something else, maybe like a storage account resource or a backend database. So instead of configuring a dummy user account and assigning that to your application and then granting permissions to resources like storage accounts and so on, instead you can work with something called a service principal. So you don't treat a service principal directly in Azure AD like you would a user or a group. You kind of do it indirectly by making an app registration. Let's go ahead and take a look at this. Here in the portal, in the left-hand navigator, I'm going to drill down to Azure Active Directory. And what I'm going to do on the left is click on App Registrations. So any existing app registrations will be shown. Of course, we're here to make a new one. So I'm going to click the new registration button up at the top, and I'm going to call this App 1. Now, this could represent a full-fledged app with a front-end user interface. Maybe that's public-facing on the internet or for an internal app, or maybe this is a type of web app that we're registering here that is some kind of a back-end service. Maybe it's an API that gets called by other components. Whatever the case is, down below it says who can use this application or access this API. Default selection is for the current Azure AD tenant, which in this case is called Azure DevOps, as evidenced up here in the upper right. But we could open this up to allow others to be able to run this app or API. So any Azure AD directory multi-tenant, as well as personal Microsoft accounts, like if they have Skype accounts or Xbox accounts, or personal Microsoft accounts only. I'm going to leave it on the default for a single Azure AD tenant, the current one that we're in, and I'm going to choose Register. Now, there's more to it than that, because what we can do is go to Quick Start, and we can determine what type of app this app registration represents, whether it's a web application, mobile and desktop application, single page app, or some kind of a background daemon service. If I were to choose web app, from here I could then choose the appropriate language. Let's say, for example, Python. When I choose that, I get a quick start on what the prerequisites are, in this case for my Python web app, how to configure the app in the portal. I even have some sample code that I can download with instructions on how to run it. Over on the left, if I go to branding and properties, I can select the logo for the app, I can specify a homepage URL, a terms of service license agreement type of URL, privacy statement URL, anything like that related to the app. If I click authentication, it reflects our change when we register the app, which was the current Azure AD tenant. If my app needs API permissions to other services, we could go ahead and click the Add Permission button. So for example, let's say that my app is going to need access to an Azure Key Vault. So I can select Azure Key Vault, and down below, I could determine the permissions. And then I can click Add Permissions to put it in effect. And it shows up down below in the permission set. Depending on the nature of your environment, you might have to go to Certificates and Secrets on the left, where you could upload PKI certificates that this app could use for authentication purposes when it requests a security token, or maybe fill in a client secret. And when we go to token configuration, this is where we can add claim information. A claim is basically an assertion about something. It provides some kind of a property value to another component that will consume that. For example, I could choose SAML for a SAML type token, security assertion markup language. And let's say that this app component for app 1 talks to something else that needs to check a user email address. Well, we could select email to be included as part of the claim, which in turn is part of the digital security token used for authentication. But the real purpose of us being here managing this as a service principal, because that's really what app 1 is here, is to use it to assign permissions elsewhere in Azure. And we can do that to a degree with API permissions, but let's close out of the app 1 registration. If I go to enterprise applications, this is another view here in Azure AD, and if I scroll down, or I could filter the list, of course, I could just say, hey, let's look for app 1. App 1 shows up also in the enterprise applications view. And from here, I might, for example, go to users and groups to determine which users and groups in Azure AD will be able to see this app, if in fact it's the type of app where users would interact directly with it. So I could click Add User and Group. For users, it currently says none selected. I could choose that. I could select a user and or group or any combination thereof. I'll select a user, and I would assign them so that they have access to the app. Now, let's say that app 1 needs very specific permissions to a storage account. So we're going to control that with role-based access control, or RBAC, now that app 1 is a service principal. And so to work with this, let's go home here first in the portal. Then I'm going to click the All Resources view. I've got a couple of storage accounts here. I'm just going to click on one of them that I want to allow access to. And I'm going to click Access Control IAM. IAM stands for Identity and Access Management. So that's where we configure our role-based access control assignments. I can click Role Assignments on the right to see current role assignments for that storage account. Then I can add a new one by clicking the Add button at the top and then choosing Add Role Assignment. Now I got some standard generic roles up here for any type of cloud resource in Azure, like owner, contributor, reader. But because we're in a storage account, we're going to notice that we have very specific storage account types of roles. Remember that a role is a collection of related permissions. So the storage blob data reader role, for example, has the permissions required to allow the reading of storage blob data. So let's say that's the role I'm interested in. I'll select it and I'll click Next. Who am I assigning that to? It can either be a user group or service principal or a managed identity. Well, a managed identity is a type of service principal that's tied to a resource like a virtual machine or a logic app or something like that. But in this case, we're going to leave it on user group or service principal. Then I'll click Select Members. What I'm going to do here is I want to select the app to give it permission. So I can just search for app 1. It's probably the quickest way of doing it. There it is. Select it. Select again. Continue on through the wizard. I'm not going to add any conditions. Just continue on and review and assign. After a moment, our notification bell icon in the upper right indicates it added the role assignment. So under role assignments here down below, if I were to search for app 1 is an app. That's what it's showing up as type. It's got the storage blob data reader role that was granted to this resource, which is shown in the upper left here as being a storage account called store account YHC2. So in the end, that's really how you work with the service principal. It's really just an app registration. It's an entity that you can then configure in various ways, such as if you need to assign permissions to it, as we've just done here for the storage account. In the Azure cloud, a managed identity represents a resource that you can assign permissions to. For example, if I've got custom code running in a virtual machine, if I enable a managed identity for that virtual machine, I can then assign that virtual machine permissions, perhaps let's say to a backend database or a storage account or whatever it is that the code in that VM needs access to. Now, if I do not configure a managed identity for that virtual machine, then I have no way to easily give it permissions. And the last thing you want to do is hard code permissions in code or in scripts, such as database connection strings and usernames and passwords, that type of thing. Managed identities, instead, lets you use the inherent trust through Azure to allow those types of things to happen instead. Now, I've been using a virtual machine as an example. It's not the only type of thing you can configure a managed identity for. You can do the same type of thing for a logic app or a function app and so on. So to get started here in the portal, I'm going to first navigate to my virtual machines view. So I've got an existing VM. I'm going to click to open up its properties. Now, when you want to work with managed identities for a virtual machine in this case, if you scroll down in the left-hand navigator, down under the settings section, you're going to see something called identity. When you click that, you're going to have two options over on the right: system-assigned identities, user-assigned identities, neither of which has been configured. Now, the difference between those two is that a system-assigned identity is a managed identity for this virtual machine that is tied to the lifecycle of this object, of the virtual machine. Meaning, if I delete the virtual machine, the managed identity goes away with it, if it's system-assigned. If it's user-assigned, it means that it is not tied to the VM. So if I delete the VM, I still have the managed identity that would exist in Azure AD. Now, there's no way to create these directly in Azure AD. They're created indirectly by what we're looking at here. So for system assigned, it's currently got a status of off. I'm going to go ahead and choose on, and then I'm going to click save. I then get a message stating that this will be registered with Azure Active Directory, and once that's done, you can grant permissions to it. Do you want to do this? Yes, we do, so I'll click yes. Okay, after a moment, it's on, and Azure has assigned it an object ID. I even have a button right here for Azure role assignments, but there are other ways to do that we'll look at. If I click my bell notification icon in the upper right here in the portal, it states that it enabled the system-assigned managed identity. So a managed identity then is really just a type of service principal that you can assign permissions to. For example, why don't we go take a look at storage accounts? So I'm going to click on my storage accounts view over in the left-hand navigator. I'm going to open up an existing storage account. What I want to do, let's say, is assign my newly created managed identity for the VM. I want to assign it permissions to be able to come into the storage account, whether it's read or write, will really depend on the nature of what's running in that VM. But what we would do here in the storage account then is go to access control IAM over on the left, and we would click add, and then add role assignment. So what we then have to do is select the appropriate role. A role is a collection of related permissions, whether it's generic reader permissions to everything in the storage account, or we could go down and specify that maybe it's storage blob data reader, if whatever's running the VM only needs reader access to blobs, or maybe contributor access to blobs. So reading, writing, and deleting the blob containers and their data. So if that's what we need, then you might have to talk to whoever created the script or wrote the code running the VM to figure out exactly what permissions are required. There's got to be that communication. In this example, I'll choose storage blob data contributor, and then I'll click next. So we can assign this role to a user, group, or service principal in Azure AD. The service principal results from registering an app in Azure AD. That's not what we did. Instead, we're going to choose managed identity, then we're going to click select members. So for our pay-as-you-go subscription, under the managed identity drop-down list, I'm going to click on it. So this is a little summary saying that you have a total of 2 system-assigned managed identities, one for a storage account, one for a virtual machine. Well, the one that we just enabled was for a virtual machine. And when I click that, the name of the VM pops up down below, Windsurf 2019-1. Yep, that's where we did it. So I'm going to select that VM and click select. Aha, so that's how it's done. So now I'm going to click next. No conditions here for these permissions, although I could click add a condition. The example given here is that if an object has a certain tag, then it might be able to read or write to an object, whatever the case might be, but I'm not going to do that. So X for the condition, I'll click the next button at the bottom, and then review and assign to complete the role assignment. After a moment, in my bell notification icon in the upper right, the added role assignment listing is shown here, so it's succeeded. If I click role assignments, because we're still looking at access control IAM for the storage account, I could then filter it, let's say, for win, because I know the virtual machine starts with win. And indeed, storage data blob contributor is the role that's been assigned to our virtual machine system managed identity. And this is better than having to write permissions directly into the code, like a storage account access key or a shared access signature or whatever's required to talk to the storage account. It's more secure and it's easier to manage. Multi-factor authentication, or MFA, can enhance user sign-in security, and the reason for this is because it uses multiple categories of sign-in information. For instance, instead of just a username and password, both of which consist of something you know, there would be some kind of additional factor, if not more than one additional factor. Perhaps a code being sent to a smartphone via SMS text, or perhaps a user in possession of a PKI certificate, or perhaps a fingerprint scan, which would be something you are, so something you know, something you have, something you are. When you start combining these, you start getting into multi-factor authentication, and it makes it harder for malicious users to break into those types of accounts. So in this case, we're going to enable MFA for an Azure AD user. So here in the portal, I'm going to start in the left-hand navigator by going down to Azure Active Directory and viewing my users. I have a user by the name of Cody Blackwell, and if I click on that account, I've got the full user principal name with a UTN. Looks like an email address. I'm going to copy that because I want to use that to sign in a moment. But let's close out of user Cody Blackwell, because when you're in the All Users view, there's a button at the top that says Per User MFA. When you click that, it opens up a new window where it will list your Azure AD users and the current status of multi-factor authentication. So for user Cody Blackwell specifically, it's currently disabled. Okay, so let's examine what the sign-in process looks like for Cody Blackwell now. Then we'll go and enable MFA, and we'll check out what the sign-in process looks like after we've done that. Okay, so I've navigated in another web browser to myapps.microsoft.com, although the URL has changed, it's been redirected, and I'm signing in as C Blackwell. So I'm going to go ahead and enter in the password for that account. And it takes me right into the myapps.microsoft.com page. So I'm currently signed in then as user Cody Blackwell. So all I had to supply was a username and a password, which is single-factor authentication, because they are both something that you know. So let's go ahead and sign out as Cody Blackwell in preparation for when we're going to come back and sign back in again. All right, back here in the portal where we've already got our multi-factor authentication web browser tab open, I'm going to turn on the check mark to the left of Cody Blackwell, and on the far right, I'm going to choose Enable. Then I'll click Enable Multi-Factor Auth, and it says the update was successful. So currently, Cody Blackwell is showing under the multi-factor auth status column as enabled, not enforced, because enabled means that we've turned on MFA, but the user hasn't signed in since to finish configuring it, and so it's not fully enforced. You also have filters at the top here where you can filter for enabled MFA accounts, one of which is Cody Blackwell, or enforced accounts. Of course, the default is any. So let's go ahead and sign back in as user Cody Blackwell to see how the process changes now that MFA is enabled for his account. So I'm signing back in as Cody Blackwell. I'm still entering the password as I did the first time, and I'll click sign in. This time, it stops me at this point and says more information required. Your organization needs more information to keep your account secure. That didn't happen the first time. That's okay. That's part of MFA. So I'm going to go ahead and click next. On the additional security verification screen, it says, how should we contact you? Authentication phone, office phone, mobile app? I'm going to choose mobile app. And it says, how do you want to use the mobile app? Do you want to receive notifications for verification that you have to approve? Do you want to use a verification code? Let's say use a verification code. Then I'll click the setup button down below. So it then gives me the steps. It says, install the Microsoft Authenticator app from the App Store for your device. So for Android, in my case, I've got an Android phone. That would be the Google Play Store. So I've already got that app. Then it says in the app, add an account for work or school, and then scan the QR code image below so it can retrieve your account information and add it to the Microsoft Authenticator app on your smartphone. So I'm going to go ahead and fire up the app and scan that image. Okay, so once I've scanned in the QR code on my smartphone, the account will have been added. And if I go into the account, there's a 6-digit code, a numeric code that counts down from 30 seconds, so it changes every 30 seconds, that I enter in to authenticate, in addition to my username and password. I'm going to click next, and then I'll click next once again. All right, so it wants me to enter the verification code on my app currently. Okay, I'll go ahead and do that, and I'll click verify. And then step 3 says, in case you lose access to the mobile app on your smartphone, what should we do? Well, I'm going to specify my phone number in case the app is a problem. So I'll select my country or region, and I'll go ahead and enter my phone number. Okay, and then I'll click Done. Okay, so that completes the initial sign-in process for user Cody Blackwell after having MFA enabled on the account. Let's go ahead and sign out. Once again, while that's happening back here in the portal, let's go back to per user MFA in the all users view in our Azure AD tenant. And notice for user Cody Blackwell, it's now showing the multi-factor authentication status as being not enabled but enforced. Okay, so I'm going to sign back in as Cody Blackwell, and I still have to enter the password. And I'll click sign in, and then it stops and says, okay, enter the code displayed on your authenticator app from your device. Okay, so I'm going to go ahead and do that. Remember that code changes every 30 seconds. And now I'm signed in. So now in addition to knowing the username and the password, I have to possess the phone with that authenticator app configured correctly so that I can enter the 6-digit code and authenticate successfully. Yet another interesting security sign-in feature related to Azure AD is the ability to enable something called MFA block. So MFA, of course, is multi-factor authentication, where we have multiple factors that are used to sign in. So username and password would be one category, that would be something you know, but in addition, a user might have to have a smartphone where they receive a code, for example, through an authenticator app, in order to sign in. So that's something you have in addition to something you know, hence multi-factor authentication. But what we can do is that in the situation that, for example, a user's smartphone is stolen or they've forgotten it somewhere, they don't know where it is, it's lost, what we can do is block Azure AD MFA authentication attempts. Because if the user lost the device, why are there authentication attempts for MFA from that device? So what happens is it blocks or denies MFA authentication attempts after you've enabled MFA block. And the user account is blocked in that way for 90 days unless you manually unblock it. So let's take a look at where to do this. First things first, in the portal here in the left-hand navigator, I'm going to draw all the way down, Azure Active Directory on the left, and then I'll click Users. So within my All Users view, I'm going to focus on one specific user, Cody Blackwell. If I click on that account, I have the user principal name, and of course if I close out of there and go to the Per User MFA button up at the top of the view, which opens up another web browser window, user Cody Blackwell is showing with a multi-factor authentication status of enforced. So the user is currently using MFA. Now I could put a check mark to the left of that name, and over on the right I could disable MFA if it's no longer required for that account. I could click Manage User Settings and require the selected user to provide their contact methods again, such as if their phone number has changed. However, I'm going to cancel out of that and close the multi-factor authentication window. And back here in the portal, in the breadcrumb trail for the links in the upper left, I'm going to click my Azure DevOps, that's the name of my Azure AD tenant, and the left-hand navigator, I'm going to scroll all the way down to Security, because what we want to do now is get to the MFA settings. So after I've clicked Security, I have a different navigation menu on the left, so I'm going to click MFA. Then I get a different navigation menu on the left once again. And what I want to do here is click Block Unblock Users. So any existing blocked users would be shown here. Nothing's been done in this capacity yet, so I'm going to go ahead and click Add. Now just before we do it, let's test that currently user Cody Blackwell can sign in. Okay, so I am signing into myapps.microsoft.com as user Cody Blackwell, so I still have to enter the password for that account, despite the fact that MFA has been enabled for it. And because MFA is enabled, it asks me in this case to go to the authenticator app on my device for that user account, where I can see a 6-digit code that changes every 30 seconds that I have to enter in to authenticate successfully. So I'm going to go ahead and enter that code in right now. Okay, and I'm able to authenticate. Perfect. Now back here in the portal, we want to block our user, and what we have to do is specify the user's email address. So I'll specify that in there for user C Blackwell, and for the reason, I'll put in misplaced smartphone, and then I'll click OK. Okay, so now Cody Blackwell shows up down below, and the reason for us blocking MFA authentication, and the date and time here. Notice we also have an unblock link. But remember, as it says above, the block will automatically be removed after 90 days if we don't do anything. Now, it might take a few minutes for this to be put into effect, but what happens is when you try to sign in and you are entering the code and trying to verify it, you get nothing. And even if that code expires, because it's only good for 30 seconds before the authenticator app will change it in my case, even if I enter in the new code and click verify, we get nothing. So we don't get a message to the effect that we're locked out, but MFA block is currently now in effect. So back here in the portal, I can select the unblock link for that account, and maybe I'll put in found smartphone as the reason for unblocking, and I'll click OK. After a moment, in my bell notification icon up at the top, the unblock was successfully configured. And so Cody Blackwell no longer shows in the list of blocked users. So we're going to try signing in once again as user Cody Blackwell, given that the smartphone that was lost in our example has now been found. So I'm signing in as Cody Blackwell again. I'm entering a current 6-digit code from my authenticator app, and I'll click verify. Okay, and then as a result, user Cody Blackwell can now successfully sign in using multi-factor authentication. One of the problems with users setting a password as part of their authentication to Azure AD is the use of common passwords that are easy to figure out, or passwords that might exist in password dictionary files used by attackers to try to break into accounts. So we can configure then in our Azure AD tenant a list of banned passwords that are not allowed to be used. So to get started here in the portal, I'm going to open up my left-hand navigator and go down to Azure Active Directory. The first thing I want to do in my Azure AD tenant is go down and take a look at licenses. And then on the far right, I want to click Manage Your Purchased Licenses, because you need to be using something like an Azure AD Premium type of license, or what I've got here, Enterprise Mobility plus Security E5, in order to be able to use some of these more advanced security features like banned passwords and conditional access policies. Now, given that I have that in place, I'm going to go back in the breadcrumb trail here in the upper left, clicking on the link from my Azure AD tenant, and then what I'm going to do is scroll down and go down to Security. Now, within Security, the next thing I want to do is go into Authentication Methods. And then next, I'll click on Password Protection. So we've got a number of interesting settings here, such as a standard account lockout threshold, which is currently set to a value of 10. This means that we can have up to 10 failed sign-in attempts in a row before the account is locked. And then the lockout duration is set here in seconds, default of which is set to 60. So these settings should be changed in alignment with organizational security policies. But that's not what we're really here for. We're here for a banned password list. So I'm going to enforce a custom list, and I'm going to specify some banned passwords. So each banned password is not case sensitive, and you need to have a separate banned password on each line in this field, up to a maximum of 1,000 banned passwords. So for example, if I put in the word password, any variation of that in upper or lowercase is automatically banned. Also, it will replace the O with the 0. That's automatically taken care of by this feature, which is pretty slick. If we are headquartered, for example, in Toronto, Canada, we might want to exclude things like sports teams' names like the Toronto Maple Leafs. Or if you're into baseball, the Toronto Blue Jays. Or basketball, Toronto Raptors. You get the idea. You can make a list of banned passwords. Now down below, the mode is set to audit. That means it will record any users that might use any of these banned passwords. I want to stop it, so I'm going to go ahead and choose Enforced. And then I'm going to go ahead and click Save. Okay, so we get a message stating it saved our password protection policy. So what we're going to do is reset a user password in Azure AD, which will trigger them to specify a new password upon next sign-in. So for that, let's go back in the breadcrumb trail to our Azure AD tenant, And let's go to the users. So in the all users view, let's say we're going to pick on user Max Bishop. So I need to have the entire user principal name here, the UPN. But I also want to click reset password here. So I'll click reset password, it'll generate it, and then I'm going to go ahead and copy it. I'm going to open a new incognito web browser window, a separate browser instance here, and I'm going to navigate to myapps.microsoft.com. Of course, I'm going to sign in as that user, Max Bishop. I'll specify the current password that we have reset it to, and I'll click sign in, which of course triggers it to tell us to update our password. So I'll re-enter that current password. Let's enter a password here that's in the banned password list. For example, I'll specify Raptors, and I'll click sign in. Okay, so then we get the message that says, unfortunately, your password contains a word, phrase, or pattern that is banned by your organization. Try something else. If I click view details, then it gives me the troubleshooting details. This might be something I specify at a help desk if I'm a regular end user and don't know what's going on. There's an error code, a request ID, and so on. Let's try something else. I'm going to put in the word password, but with an uppercase P. Bear in mind, in our banned password list, we specified all those lowercase letters. And I'll click sign in. Well, this time it says, we've seen that one too many times before. Choose something harder to guess. Okay, so I'm going to enter a password that is not in the banned password list. I'll confirm it, and I'll click sign in. Back here in the portal, I can monitor that type of activity where users are attempting to use a password that's been banned. So I'm still in Max Bishop's user profile in my Azure AD tenant. So what I'm going to do then is scroll down in the left-hand navigator, and under activity, I'm going to click audit logs. Here, over on the right, I can see not too far down under status trees and password banned. I'm going to click on that. So here we have a date and timestamp where users trying to change their password, but the password was banned by our admin policy. This can be important information if the user is contacting the help desk and doesn't understand exactly why they're unable to log in or reset their password. In this case, we can provide a definitive answer because it's on the banned password list. Conditional access policies. These allow us to specify a series of conditions that need to be satisfied before a user can sign in, and perhaps even using only a specific type of device. Now, in order to work with conditional access policies, you need to have an Azure AD Premium or some other kind of product license that will allow for those more advanced Azure AD tenant features. So let's get started then here in the portal. We're in the left-hand navigator. I'm going to start by drilling down into my Azure Active Directory tenant. Now, what I'm going to do is begin by looking at licenses. So on the left, I'm going to scroll down and click licenses, where on the far right, I'll click manage your purchased licenses. And from here, we can click the try buy button, and we can go through a free trial for Enterprise Mobility and Security E5 or Azure AD Premium P2, which is included with Enterprise Mobility and Security E5. I've already enabled that one, and I've already got it assigned to a number of users. Now, without any of these types of licenses for your Azure AD tenant, you won't be able to partake in some advanced features like conditional access policies. So let's go back to our AD tenant, where on the left, I'm going to scroll down until I see security, then I'll click security on the left, and then I'll click conditional access. I'm going to begin by clicking named locations. What we can do is add specific countries or IP address ranges as a named location, which can be referenced then within a conditional access policy, as in users must be signing in from one of these locations. So let's add one of each. Let's add a country's location. I'm just going to call it Canada. And in the drop-down list below, we can determine the location by the IP address, if you're using IPv4 addressing, or by GPS coordinates. So depending on what your needs would determine what you would select here. Let's leave it on GPS just for fun. And in the search for Canada down below, turn on the check mark to enable it and click create. So we've just created a named location of Canada based on GPS coordinates. I'm going to add an IP ranges location up at the top. I'm going to call this headquarters. I'm going to turn the check mark to mark it as a trusted location. Then I'll click the add button down below to enter a new IPv4 range. Notice I can also have specified an IPv6 range. So I've entered in an IPv4 range in CIDR notation, CIDR, classless interdomain routing, and I'll click add and then create. So I've got two named locations then that I've created, Canada and headquarters. Let's go to policies on the left. The first thing we should bear in mind is that when you go to build a new conditional access policy, you can build it from a template. So let's just take a look at that at least. Create new policy from templates. Now we can base this template. Now for the template category, it can be based on identities for users or apps or on devices. We'll start with identities and I'll click next, which puts us under select template. So there are a bunch of great templates here. Require multi-factor authentication for admins, or require multi-factor authentication for all users, or require multi-factor authentication for Azure management. I can select any one of these and click View Policy Summary to get some details shown over here on the right about that particular policy. I'm going to click the previous button because I'm going to choose devices, then I'll click next. So again, we're under select template, but this time for devices. So for example, block access for unknown or unsupported device platforms, or don't allow persistent browser sessions. And again, I could click the View Policy Summary link to view the details about that particular selected summary. So we have a number of great templates on which to base our new conditional access policy. However, I'm going to click X in the upper right because I'm going to add a new policy just by choosing Create New Policy. So no template involved. I'm going to call this Canada HQ for Canada Headquarters. I'm going to call this Canada HQ for Canada Headquarters. Down below, I can assign this to users or workload identities, which represent apps. So I'm going to click on the link down below, and I want to include all users in this, but I can exclude certain accounts, such as administrative accounts. So under exclude down below, I'll turn on users and groups, and I will exclude my own account, IT Demo 2, and I'll select that. I want to control access to an app, so I can click on the link under Cloud Apps or Actions, and I'll choose Select Apps, and maybe I'll choose something like Cisco WebEx, assuming that's something that we use, and I'll choose Select. Continuing on down through the policy, we don't have any conditions yet, so I'm going to click the link under Conditions. We've got various types of things that we can look at. The user sign-in risk, the device platform, locations, client apps that are installed. Let's start with device platforms. I'll click the Not Configured link under it. I'll turn on device platforms by clicking Yes. Then I'll select device platforms. And let's say I'm interested in Android devices. That's what I want to include in this conditional access policy. Then I'll click Done. For locations, well, this is where if I click on that link, I can start to select specific locations that we have configured, like Canada or headquarters. So let's say I choose headquarters as a named location. I'll choose select. And then down below, we have to determine, do we want to grant or revoke access to things? Well, I don't want to block access. I want to grant access. And at the same time, maybe I'll require multi-factor authentication. So I'll choose select. Now at the bottom, it's enabled for report-only mode or audit mode, where it will track user connections where this policy would apply, or you can turn it on or off. I can leave it on report-only mode and choose create, because what we can do here in the policies view is we can click the what if button up at the top. Now you might have multiple policies that might apply, let's say, to a given user. It's a cumulative type of approach. So if one of those policies requires MFA sign-ins and the other requires a sign-in from Canada, then both of those conditions must be met. In this case, we only have one policy, but we can run the what if scenario against it. So I'll click what if. I can specify a given user that I want to check to see what they would be affected by in terms of conditional access policies. I could specify an IP address, and I could specify a country. So let's say I specify Canada. So if we had this user signing in with that IP address from Canada, and let's say that they were using an iOS device, there are many other things that we could check here, but at this point, I'm going to click the what if button. I'm going to scroll down. So it says policies that will apply. There are no policies that would apply given the conditions that I've set up above. However, if I choose policies that will not apply, notice Canada HQ would not apply, again, based on our configuration up above. If we have IT Demo 1 signing in with that IP from Canada using iOS. So why wouldn't any policies apply? It says reasons why this policy would not apply. Device platform. That's correct because our policy is configured to look for Android devices, not iOS. So I want to go back up and change that up. Under device platform here, I'll choose Android, then I'll scroll down and click what if. So under policies that will not apply, we no longer have anything shown. But if I click policies that will apply, Canada HQ would apply given those settings above. And of course, it would require multi-factor authentication. Now, once you've tested this out and you feel like you want to put it into motion, you can go ahead and open up your policy and you can turn it on under the enable policy section and then save the change. If you've ever done IT support for an organization or worked at the help desk, then you've probably received password reset requests where inevitably users just forget their passwords and can't sign on. Now, what we can do to reduce the burden on the help desk is we can enable the self-service password reset or SSPR option here in the Azure AD tenant. Now, we're also going to take a look at authentication methods which are used by the self-service password reset option. So let's get going here in the portal. I'm going to navigate to Azure Active Directory and I'm going to go to the users view. So I have a number of users that exist already. Now we know that if a user forgets their password from the technician side, we can open up a user account here and we can reset the password for them. But we don't want to have to do that. We don't want to be involved. So what I'm going to do then is click the password reset option over on the left. Now before I enable that, I'm going to click authentication methods. We can determine how many authentication methods are required to reset forgotten passwords, 1 or be it 2. So down below, we have either email that can be used to reset a forgotten password, such as sending a code to an account or a link to an account, and mobile phone SMS text. But there are other options like mobile app code, or by selecting security questions and specifying the number of questions required to use this feature. So then we can click the no security questions configured item and add some. They can be predefined security questions or we can have custom ones. So I'm just going to turn on a couple of these and then I'll click OK and OK once again. Okay, so now I'm going to save these authentication methods. Now on the left, if I click registration, it is set by default to require users to register when signing in. Even for the first time, this means registering their security information to allow for password reset. Under notification, should users get an email message stating that their password has been reset? Should admins be notified? So we have a lot of these options. Under customization, I can customize the help desk link and specify a URL. Of course, I actually enable this by going to properties on the left. Currently, self-service password reset is enabled for none. Now it can be selected for all users in Azure AD or selected users. So I can select a group. For example, I'll choose Project A members and select so only the members of that group have the password reset option enabled. And then I'll go ahead and save it. So if I go back to my Azure AD tenant and go to groups and open up Project A members, who's a member of that group? Lucas Brenner and Janice Carter. Great. Let's test how this works. Trying to log in as user Lucas Brenner. So user Lucas Brenner is currently signed in to myapps.microsoft.com. So I'm going to click on the username in the upper right and I'm going to choose sign out. And then we're going to go ahead and try to sign right back in, but we're going to specify an invalid password. Now, if we enter an incorrect password and try to sign in, it just tells us it's incorrect, and that's what the user would experience. Now, at some point, they might realize they do not know the password. So that's where we would click the Forgot My Password link. So we first have to verify that the email address is correct, then enter the characters in the picture, which I will do, and then I'll click Next. But we run into a problem. Because password reset hasn't yet been set up. The user hasn't registered for this feature. So it's important that users sign in at least once after we enable self-service password reset, that they sign in successfully and configure it accordingly. Okay, so no problem. Now we know how that behaves. Let's go ahead and sign in once again. Now, of course, I do know the password for the account, so let's step through what happens when things are done in the correct manner. Okay, so user Lucas Brenner is being prompted that more information is required. No problem. Next. So the first thing is entering phone number information. Okay, no problem. I'll go ahead and do that. And I'll leave it on text me a code. I could opt to have it call me and read the code to me. I'm okay with text, so next. I'll enter the 6-digit code that was texted to my smartphone and I'll click Next. Okay, so now my phone is registered successfully. Next. So we only require one sign-in method. That's phone in this case, so we're good to go. So I'll click Done. Okay, and now we were able to sign in as Lucas Brenner. Now that the user is registered, let's sign out. We're going to try to sign in, but we're going to click Forgot My Password. And we're going to enter the code shown in the image and I'll click Next. This time, it's working. It says, okay, you want to get back into your account? We're going to need your phone number. So I'm going to go ahead and enter the phone number. And I'll click Text. And I'll enter the 6-digit PIN that was sent to my phone and I'll click Next. Now it wants me to enter a new password. This is working. So I will enter and confirm a new password for this account and I'll choose Finish. And it says, your password has been reset. To sign in with your new password, click here. Okay, I'm going to click that. And away we go. Let's see what happens. Yes, it looks like we are able to now successfully log in, despite the fact that the user forgot the password, and technicians were not involved other than the initial configuration. Now back here in the portal, if I go back in and take a look at the user settings for password reset, remember, we only required one authentication method. So if we want to require two, if we want to maybe force it to be done through security questions or email and not SMS text, we can just uncheck and set these options accordingly. The self-service group management, or SSGM feature of Azure AD is a great way to help reduce the burden on the help desk. It's kind of like self-service password reset, where users can reset forgotten passwords, but with self-service group management, we can configure it such that users can request to join a group, and maybe it needs to be approved by an admin or a group owner, or maybe it just allows them to join the group automatically. And we know as IT admins that working with permissions at the group level is much more efficient than doing it on a user-by-user basis, at least when it comes to users with the same types of permissions needs. So we're going to take a look then at how to configure self-service group management. So here in the Azure portal, I'm going to start by navigating into the Azure AD tenant that I'm currently using, and I'm going to click Groups. So I'm going to click a group called Project A Members, and then I'll click Owners on the left. It currently states that no owners have been found for the Project A members group. So I'm going to click Add Owners, and I'm going to add user Lucas Brenner. He's going to be the owner of the group. Now at the same time, let's double check the membership here. I don't want Lucas to be a member of the group. Not that he can't be, but I don't want that. So Janice Carter is currently the only member of the group, and Lucas Brenner is the owner. Okay, so let's go back to groups here in our Azure AD tenant. What I'd like to do at this point is go to General over on the left. Over on the right, I then have the option for self-service group management, which is turned off by default. It's set to no. So I'm going to choose Yes. Now that's for the option specifically labeled Owners can manage group membership requests in the Access panel. We'll demonstrate that after. Down below, we can restrict the user ability to access groups in the Access panel. So I'm not going to do that. So at this point, I will click Save. Okay, I'm going to log in as user Lucas Brenner. And you might wonder, log into what? Because the URL has since changed from when I entered it. I'm connecting to myapps.microsoft.com, and I'm going to log in as Lucas Brenner. Okay, so user Lucas Brenner is now signed into myapps.microsoft.com. Now, when Lucas Brenner is signed in, though, where do we go to manage any groups that he is an owner of? The answer is to go up under My Apps up at the top in the upper left and to choose My Groups, which is going to open a new web browser window. So on the left, we've got a heading labeled as Groups I Own. And sure enough, there's Project A members. Lucas Brenner is the owner of that group. Then on the right, there's groups I'm in. So apparently Lucas Brenner is in a couple of other Azure AD groups. So for instance, if Lucas Brenner were to click on Project A members, the current members will be shown on the right. And that includes currently only Janice Carter. But there was a little plus sign over there where Lucas Brenner could add a member. Let's say searching for user Marcia, there's Marcia Lynn, and adding her to the group, and okay. Okay, so this is all done through this web portal, which is great. From a convenience standpoint, it also means the tech team, IT technicians, help desk techies, don't have to do this. But users can also request membership in a group. Let's check out what that looks like. Okay, in a different web browser, I'm signed in as a completely different user, specifically user Max Bishop. So Max Bishop then can click on My Apps in the upper left and choose My Groups, which as usual opens up a new window that shows the groups that Max owns, of which there are none, says no groups found, and then any groups that Max is in. He's currently in the Milan users group. But notice that there is a link here for Join Group. I'm going to go ahead and click on that. So let's say that Max Bishop wants to become a member of the Project A members group. So I'm going to go ahead and select that group. But then it says on the right, this group is not available to join. Even if I click show more details, it's just not showing me anything else that's helpful. Showing me the members of the group, but that's it. Okay, so the answer lies in the fact that the owner of the group needs to allow users to request to join a group. So let's go back to user Lucas Brenner, who is the owner of this group, to see how that's done. Okay, so back here as Lucas Brenner, the owner of the group, we're going to go back into My Apps, My Groups. He owns Project A members. We'll click on that, and then we'll click Edit Details. The group policy for this group says only the owner of this group can add members. Aha! Okay, so let's open that up. And we can either say this group is open to join for all users, or this group requires owner approval. I'm going to go with the owner approval option, and I'll click Update. Okay, so back to Max Bishop. Let's go back from where we were. Let's go back to Project A members. This time on the right, it says Join Group. Perfect. And I'll just add a quick little message, and I will request to join the group. So that's going to be sent off to the owner, which of course is Lucas Brenner. Now back here is Lucas Brenner. When I go back into group management, I've got a little notification on the bell icon in the upper right. And this is a notification for Max Bishop wanting to join the group. So I go ahead and choose Approve and Approve. So now, if I go into the Project A members, and you might have to click the refresh button, Max Bishop is now showing as a user. So this whole group self-management thing is designed to reduce the burden on IT technicians. They can use their time to do things that are higher priority. An Azure AD access review should be run periodically to check that users that are members of groups, perhaps to get access to an app, still require access to that app. One security principle is the principle of least privilege. And what this means is that we don't want to assign more permissions than are required to perform very specific job functions. So in other words, we don't just want to throw people into groups that have a lot more privileges and permissions to resources than a user might need. Now, even though at the time that a user becomes a member of a group, they might require permissions to something, that might change over time, such as if they change job roles, or if you're working with dynamic group membership and maybe it's based on city or some other attribute and a user all of a sudden falls under the scope as now being a member of that dynamic group. You want to be able to keep on top of this. And that's always an important aspect of your security program in your organization, periodic access reviews. So the first thing I'm going to do here in the portal is I'm going to go into my Azure AD tenant. And I'm going to start by going to licenses on the left because you need to be using a certain type of product license to be able to work with Azure AD Access Reviews. So I'm going to click all products. What I've got here is a trial for Enterprise Mobility and Security E5. You need that or an Azure AD Premium type of license that's been assigned to the appropriate users in order to access more advanced features like conditional access policies and our topic access reviews. So if I don't have one of those product licenses, I can click try or buy, and if I haven't already signed up for it with my Azure account, I can get a free trial of either of those, or I can actually go to the purchase services catalog to buy it. Okay, let me go back to my Azure AD tenant because access reviews are nested underneath groups. So I'm going to go to groups, and I'm going to go to access reviews. Now that's if you want to create an access review to check that people that are in groups should still remain in groups, because you know how it is over time. Someone has moved on in a different job role, yet they're still a member of a group that gives them access to stuff they don't need access to. That's a security violation. So I've already got a review that I've created called Review 1. The reason I've created it previously is so that when we open it up, I could show you that after it has expired, depending on how you've configured the default action for the review, it might, for example, deny people from being a member of a group if they don't respond. Because you can have the individual people involved with determining, yes, they should be in the group, or no, they shouldn't be. Now, of course, I could create a new access review. So for teams and groups, select groups. So maybe I want to look at a specific group to determine if the members of that group really still need to all be members. So I would select the group, click Next Reviews. I can choose who the reviewer should be. Perhaps it would be the group owner or somebody else. I can set fallback reviewers if this reviewer, for example, is away on vacation or out of the office. We can specify the number of days the review will take place and how often it should occur, whether it's a one-time only, weekly, monthly, quarterly, and so on. I'm going to use one time. Under Next Settings, this is where we can choose to auto-apply results, such as removing people from the group if they don't respond and say, yes, I should be in this group, I still need this access. So if reviewers don't respond, the default is no change, but I can choose remove access, approve access, or take the automatic Azure recommendations. Now what I had done in my previous review that we looked at was removed access. So now we can continue on and create this access review. However, that's for group memberships. I'm going to go back to my Azure AD tenant. I'm not going to save that one. Because if I go down to Enterprise Applications, of course I get a list of apps that are available here in Azure AD, but if I scroll down further in the left-hand navigator, I can look at access reviews for applications. Now I don't have any here, so I can click New Access Review up at the top, and I can choose Select Application, let's say App 1, and I'll choose Select. Now the scope can be for guest users or all users that are affected by that app. In other words, all users that might have been assigned permissions. So I'll select that and click Next. And then I can choose, for example, that users will review their own access to determine if they should have access to the app. Maybe the duration here will be 3 days, and this is a one-time only, although it should be recurring. We can also, again, auto-apply results to the resource, but I'm not going to turn that on this time. And down below under Advanced Settings, whoever's reviewing this, in this case the users that have app permissions, are going to have to specify a justification as to why they still need access. And there are other things like email notifications and reminders. I'll leave those on. And I'm going to call this App 1 Security Permissions Review. And I'm going to choose Create. And after a moment, it shows up in the Access Reviews list here in my Enterprise Applications in my Azure AD tenant. So if we go ahead, and if we were to take a look at App 1 to see who has permissions, if I click on Users and Groups on the left, user Lucas Brenner has permissions. So we're going to sign into myapps.microsoft.com in a different web browser as Lucas Brenner. Now, when I'm signed in as Lucas Brenner, then I have app 1 available, of course. But if I go to my apps, my access, and if I click access reviews over on the left, then I'm going to see my app 1 security permissions review under groups and apps. If you don't see that, it's just not refreshed yet. Sometimes it takes a few minutes before it shows up for a user. At any rate, here it is. So I can click on that as user Lucas Brenner, and it says, do you still need access to the app 1? I'm going to choose yes, indeed, I do. The reason, required for my job role. And then I'll click submit. So in this case, the users themselves get to specify whether they still need access or not. Let's go back to the portal and check out how it shows up there. So I'm back in the portal. I'm still at my enterprise applications looking at access reviews. I'm going to click on the access review that we created. And in the progress, we've got one user that was approved. And that, of course, is the user that we just did it as, Lucas Brenner. If I click results over on the left, then we have Lucas Brenner shown here as approved. Notice under recommended action, if we had enabled to do that in our access review, it would have denied Lucas Brenner because he last signed in more than 30 days ago. Azure AD Connect is a feature of Azure AD that allows you to link your on-premises Active Directory domain to your Azure AD tenant. Now remember, you could have multiple Azure AD tenants, and so you'd have to determine which one of those that you want to link to your on-premises Active Directory domain. Okay, so we're talking about linking Active Directory in the cloud and on-prem, but why would you do that? Well, the first issue is that you don't want to duplicate user accounts. Let's say you've got 1,000 user accounts in your on-premises Active Directory domain environment, and now you want those users to have access to cloud-based apps. Now, if you don't use Azure AD Connect, how will you authenticate those 1,000 users to those cloud-based apps? Well, you could recreate all of those accounts in Azure AD. That sounds like an awful lot of work. There must be an easy way, and there is. It's using Azure AD Connect. This way, users could continue to use their familiar on-premises credentials to sign in to whatever they need on-premises, and then they would also be authorized, based on the permissions you grant to them, to use certain apps in the cloud, all without recreating or duplicating user accounts. Well, this sounds useful. Let's dig deeper. One consideration with Azure AD Connect is you have to deal with an AD custom domain name, so a DNS domain name. The default DNS domain suffix when you create an Azure AD tenant is .onmicrosoft.com. So if my company is quick24x7 and that's what I call my Azure AD tenant, the DNS domain name will be quick24x7.onmicrosoft.com. Well, when you want to link your Azure AD tenant in the cloud, your on-premises domain, you're going to have to create a custom domain name in Azure AD that matches whatever the name of your on-premises Active Directory domain name is. So on-premises, if it happens to be called quick24x7.com, well, you're going to have to create that as a custom DNS name, same name, in Azure AD, and you need to verify ownership of it. So what's going to happen in Azure AD then is you're going to create a custom DNS domain name, in our example, quick24x7.com, and then Azure is going to prompt you to create a record, a resource record in your DNS zone, because you have to already own it externally outside of Azure. You're going to be prompted to create a record with a very specific value. And then you would use whatever tools you normally use to manage your DNS domain to add the record with that specified value. When you go back to Azure and validate that, it'll check that you created that record with that special value. And if you did, it proves that you own it. Otherwise, how would you have created that? And so you can't use the custom DNS domain name until it's been validated. But that happens pretty quickly. You shouldn't have to wait very long after you've created the required DNS record in your external DNS domain name registrar. Okay, so that's an important component. The other thing to think about in terms of components is that you need access to at least one on-premises writable domain controller. Now, writable is important here because Microsoft supports something called read-only domain controllers, or RODCs. You don't want to deal with that. It needs to be a writable domain controller. A domain controller is a Windows server that is joined to an Active Directory domain, and it contains a replica or copy of the Active Directory domain database. So it's on one of those writable domain controllers that you have to install the Azure AD Connect agent, which you can download straight from the portal. At least there's a link in the portal. And we know that in the cloud, you've got to have an Azure AD tenant with a custom domain name that matches your on-premises domain name. And when it comes to authentication, of course, when you configure the Azure AD Connect agent on-premises, you'll be prompted to sign in not only to your on-premises Active Directory domain with admin credentials, but also your Azure AD tenant with admin credentials. So let's take a look at this in the portal. Here in the portal, I've already navigated to my Azure AD tenant, and on the left, I've clicked Azure AD Connect. On the right, next to last sync, it says sync has never run. All right, so this is not currently linked to an on-premises Active Directory domain, but we do have a link to download Azure AD Connect. So you would download that to your on-premises writable domain controller and then run the installer. At which point you'll get these types of installation screens. The first of which is whether you want to do an express setup or a custom setup. The express settings are shown here, so if you want to configure Azure AD Connect differently, then you would do a custom installation, such as if you didn't want to use password hash synchronization. We'll talk about that in a moment. The next part of the installer of the Azure AD Connect agent is the user sign-in method. Password hash synchronization is selected by default. What this means is that a hash of the user password is generated on the on-premises domain controller, and only the hash of the password is synchronized into the cloud in Azure AD. Even though it looks like when you view your user accounts in Azure AD, you've got all your user accounts that exist on-premises that you've specified should be synced, it doesn't actually replicate all of the user properties. You can also enable pass-through authentication, which means that if a user, for instance, attempts to access a cloud-based app, Azure AD will intercept that request and pass it off through the Azure AD Connect link to an on-premises domain controller for authentication. You can enable federation with Active Directory Federation Services, ADFS, or federation with Ping Federate. You could also enable single sign-on. So there are a number of options. And the great thing about this is you can launch the Azure AD Connect sync agent on that domain controller at any point in the future to change this configuration. But when you do that, it pauses synchronization. The next thing you'll be prompted to do is to authenticate with admin credentials to your Azure AD tenant, followed by authenticating to your on-premises Active Directory domain, after which you can then determine if you want to enable domain and OU filtering. So for example, you could turn on the checkmark for any OUs that contain users that you want to sync to Azure AD. Although we'll use the term sync loosely because we're not synchronizing all of the user attributes into the cloud. Then you get to the optional feature screen, where you can enable options like password write back. So if the user changes their password in Azure AD, then that gets written back, of course, to the on-premises domain controller. Now, once this is enabled, it is left running in the background all the time. It's a service that runs on the on-premises domain controller. And so as you add users on-premises, they will be synced into the Azure cloud, given that they're part of your domain and OU filtering. Okay, in this demonstration, I'm going to configure Azure AD Connect. Now, the purpose of using AD Connect is to link your on-premises Active Directory domain to your Azure AD tenant. Now, you would do this because you might have a lot of user accounts in your on-premises Active Directory domain, and you want them to be able to authenticate to cloud apps, but you don't want to recreate all of those user accounts again in the Azure cloud. So that's where AD Connect comes in. Users can continue to use their credentials that they're already familiar with to access on-prem as well as cloud-based services. So let's take a look at what's required to make this happen. So I'm in the portal, and I'm currently in one of my Azure AD tenants. Now, the first thing you have to think about is you have to have an Azure AD tenant that you want to link to your on-premises Active Directory domain. And that might not be the default tenant that you got when you signed up for your Azure account. So if you haven't already, you need to create the appropriate tenant. So here in the portal, I'm going to go to Azure Active Directory for my current tenant, but I want to switch to a different one that I want to link to my on-premises Active Directory domain. So I'm going to click the Manage Tenants button over towards the upper right. And I've got an Azure AD tenant that I've already created called Quick 24x7 Test. So I'm going to select it, and I'm going to click the switch button up at the top. Then, now that I'm in that Azure AD tenant, if I scroll down on the left, I can then click Custom Domain Names. I have a verified custom DNS domain name here called quick24x7test.info. So I actually own that DNS domain outside of Azure already, and that's how I verified it. Now here in my on-premises Active Directory domain environment, I've got a domain called quick24x7test.info. So that domain name matches the custom DNS domain name that I've configured already for my Azure AD tenant. Those names have to match. Now notice I do have an OU here called East, in which I have a couple of users, East User 1 and East User 2. And so back here in the portal, what I want to do in the left-hand navigator, because I'm still within my Azure Active Directory tenant, is I'm going to click Azure AD Connect on the left. It says it's not installed, but I do have a link here to download Azure AD Connect. When I click that link, it opens up a new web browser window where I can then download the installer for this, because this is what needs to be downloaded and run on my on-premises writable domain controller. Okay, so now that I've got Azure AD Connect downloaded, it's a Microsoft Windows installer, so an MSI file. I'm going to go ahead and right-click on it and choose Install. That brings me to the Welcome to Azure AD Connect screen. So I'm going to agree to the license terms as well as the privacy notice, and I'll click Continue. Now I can either use the express settings, which are shown here. It says if you've got a single Windows Server Active Directory forest, which I do, it'll configure synchronization for identities in the current AD forest that the server is a member of. This is a writable domain controller I'm doing this on. It'll configure password hash synchronization from on-premises AD to Azure AD. That means that it's not actually synchronizing passwords into the Azure cloud. Instead, a hash is taken locally, and the hash is what gets synced into the cloud. Or I could choose Customize, where I could specify a custom installation location or use my own SQL Server database for the Azure AD Connect product, and so on. However, I'm just going to go back to previous and say Use Express Settings. Now, the first thing I have to do is connect to Azure AD. So I need to connect as a user that has the Azure AD Global Administrator or Hyper Identity Administrator credentials. Back here in the portal, I'm going to navigate to the users within my Azure AD tenant. I have a user by the name of Cody Blackwell. And if I click on that account and click on Assigned Roles on the left, notice that Cody has the Global Administrator role that's already been assigned. So those are the credentials I'll use here in the Connect to Azure AD part of the wizard. So I'm going to click Next. So I'm going to enter in the credentials for my local Active Directory domain with an admin account, and then I'll click Next. Okay, it says it's ready to configure. It's going to install the sync engine, configure the connector, enable password hash synchronization, and then start the synchronization service. I can come back and reconfigure the details related to this if I wish in the future, such as choosing something other than password hash synchronization, maybe pass-through authentication, where when Azure receives a request to authenticate, it simply passes it back to the on-premises domain controllers. At any rate, I'm going to go ahead and choose Install. Okay, so now the configuration is complete. So I'm going to go ahead and choose Exit. So remember we said that we could come back and change the configuration of our Azure AD Connect environment. We can do that. There's an Azure AD Connect icon that's been placed on the desktop that we can go ahead and launch. Now it does say that the synchronization service will be suspended while you're in this wizard, but I could click Configure. And this is where, for example, I could choose Customize Synchronization options and click Next. So it's asking for Azure AD Global Administrator credentials. But on the left, we see that we have the option of specifying domain or OU filtering. If we really want to synchronize certain objects in the Active Directory hierarchy, like a specific OU. However, I'm not going to do that. I'm just going to go to Previous, and then Exit. Now back here in the portal, in our Azure AD tenant, if I were to go down on the left and click Azure AD Connect, after it's had time to do some synchronization, even though we click refresh, we don't see change now, it will eventually say that Azure AD Connect sync is enabled. It still reflects not installed here. However, if I go to the users view, notice we've got some users that didn't exist here before, such as East User 1 and East User 2. Those were accounts in our local Active Directory domain that were synchronized here to the cloud, and we've also got this automatically created on-premises directory synchronization agent account that was created. So at this point, we've linked our Azure AD tenant with our on-premises Active Directory domain. All right, so in this course, we've examined how to configure various Azure AD authentication and authorization settings. We did this by exploring authentication and authorization mechanisms, identity federation, and Azure Service Principals, as well as managed identities. We then managed Service Principals and managed identities in Azure AD. Next, we enabled Azure MFA and MFA block. We configured conditional access. We also enabled self-service password reset or SSPR and self-service group management SSGM. Finally, we enabled an Azure AD access review and enabled Azure AD Connect. In our next course, we're going to move on to explore how to manage management groups and resource groups.